In this video, we'll be talking about const in C++. Const is basically for ensuring a variable keeps a constant value throughout the code. In other words, if you're adding this const keyword to a variable, you cannot change its value later. Constant variables must be initialized when they are declared, so in the code below, I is constant, so if you try to change its value afterwards, you will get a compile time error. Pointers can also be declared using the const keyword. When we use const with pointers, we can do it in two ways. We can either apply const to what the pointer is pointing to, or we can make the pointer itself a constant. In a declaration, the const keyword gets applied to whatever is on its immediate left. And if there's nothing there, it gets applied to whatever is on its immediate right. So in this example, u1 is a variable pointer to a constant integer since cont has nothing to the left, so we make const apply to whatever is on the right, which is the integer type. Here, u2 is another way to write a variable pointer to a constant integer, since the const here will be applied to the left integer type. u3, on the other hand, is a const pointer to a variable integer, since the pointer symbol is to the immediate left of the const keyword. And the last two, u4 and u5, are just different ways to write a constant pointer to a constant integer. A variable pointer to a constant integer means that the pointer is pointing to a const variable. These are useful as they can be used to make strings and arrays immutable. Const pointers to non-const variables means you can't change the pointer, but you can change the value it points to. The constant pointer to a variable is useful when you want a storage that can be changed in value but not moved in memory. Here, x is a variable integer, and w is a const pointer. If we change the value of x, we are able to change the value which w is constantly pointing to. Now, we will talk about how const is used with objects and functions. Class data members can also be defined as const. These are data variables in a class which are defined using the const keyword. They are not initialized during declaration, but with an initializer list which we have used before. If a function argument is declared as const, and it cannot be changed in the body, or else an error will occur. Here, function change param will give an error since the function declares the argument z as a constant, then tries to change its value. Objects also have class-specific const functions which ensure that data members are not modified in the function body. This means that these const member functions cannot change data members of an object. As seen with the call of the const function change variable I giving an error whenever trying to edit member I. Both of these functions can be called with both const and non-const parameters. An object can also be declared as constant when an object is declared or created using the const keyword. Its data members can never be changed. Here we can see that unlike a normal object, if a const object attempts to change a member variable, it will get a compilation error. The only way around this is declaring a variable mutable. The mutable keyword is used with member variables of a class which we want to change even if the class is of const type.